we've already talked about the hypotenuse. It is always positive. So the trig functions will have sine, we'll have cosine, we'll have tangent. So I know that sine, using SOHCAHTOA, sine is opposite over hypotenuse. So if the opposite side is positive and the hypotenuse is also positive, that means the answer for the sine value would also have to be positive. So in quadrant 1, the sine is positive. Now for cosine, cosine is adjacent over hypotenuse. If the adjacent side is positive and the hypotenuse side is positive, then a positive over a positive, the cosine value would have to be a positive. And tangent is sine over cosine. So if the sine is positive and the cosine is positive, that means the tangent would also be positive. And the other three trig values would be cosecant, secant, and cotangent. Well, if the sine is positive, if I invert that fraction, it's still going to be positive. So that means the cosecant is also positive. If the cosine is positive, when I invert the fraction, it will still be positive. So the secant is positive. Same thing with tangent. The cotangent will be positive as well. So notice in quadrant 1, all of the values are positive. Now the two main ones we concentrate on are just mainly sine and cosine. If you know the signs of sine and cosine, then you can determine the other four. Now, draw a terminal side in quadrant 2. And when you draw your right triangle, make sure you drop from the terminal side to the x-axis. And here is my reference angle. Now talking about the base, is the base of this triangle going to be positive or negative? Yeah, it's to the left of 0, so that one has to be a negative. And what about the height of that triangle? Positive, and we know that the hypotenuse is always positive. So using SOHCAHTOA, sine is opposite over hypotenuse. So the opposite side is positive, the hypotenuse is positive as well. So what does that tell me about the sine? It has to be positive. So if the sine is positive, the cosecant is also positive. For cosine, cosine is adjacent over hypotenuse. If the adjacent side is negative and the hypotenuse is positive, what would the sign be for cosine? Negative. And if the cosine is negative, then the secant is also negative. And tangent is sine over cosine. So if the sine is positive and the cosine is negative, that makes the tangent negative. And if the tangent is negative, then the cotangent is negative as well. And again, we mainly just focus on sine and cosine. Now, moving on to quadrant 3, draw a terminal side in quadrant 3. And draw your right triangle where that vertical piece is going from the terminal side to the x-axis. And let me put my theta in here. So we already have the base, or the top part of the triangle, or the top side of the triangle is negative, but what about this piece? That would be negative because it's below 0. And the hypotenuse is always positive. So notice for this triangle, the opposite side is negative, and the adjacent side is negative as well. So let's go ahead and write down the 6 trig functions. We'll have sine, cosine, tangent. We'll have cosecant, secant, and cotangent. So if sine is opposite over hypotenuse, that would be a negative over a positive. So that tells me the sign would be negative. Cosine is adjacent over hypotenuse, so the cosine would be negative. And if tangent is sine over cosine, then a negative over a negative would be a positive. If the cosecant is if the sine is negative, the cosecant is negative. If the cosine is negative, the secant is negative. If the tangent is positive, then the cotangent is positive. And again, we just mainly concentrate with sine and cosine. One last one. Draw a terminal side in quadrant 4. draw your right triangle by going from the terminal side to the x-axis. And here's theta. We already have the top side marked as positive. So this is a positive. But what about this other side, the other leg of the triangle? Yeah, that one has to be a negative because it's below the x-axis. And we know that the hypotenuse is always positive. So go ahead and write down the 6 trig functions. We'll have sine, cosine, and tangent. We'll have cosecant, secant, and cotangent. So for the sine, it would be opposite over hypotenuse. So a negative over a positive would be a. So sine is negative, cosecant is negative. For the cosine, adjacent over hypotenuse. So a positive over a positive would be a positive. If the cosine is positive, that means the secant is positive. And tangent is sine over cosine. So a negative over a positive would be a negative. So cotangent is also negative. And again, we just concentrate on sine and cosine. Now just to recap, let's make this a little bit more streamlined. So let's put S for sine, C for cosine in all 4 quadrants. So notice in quadrant 1, sine is positive, cosine was positive. In quadrant 2, sine is positive, cosine is negative. Quadrant 3, sine and cosine are both negative. And then in quadrant 4, the sine is negative, the cosine is positive. Now, there's some similarities diagonally that I want you to look at. So let's take a look first at quadrants 1 and 3. What do you notice on that diagonal? Yeah, notice in quadrant 1 they have the same sign. So they're both positive in quadrant 1. They're both negative in quadrant 3. Now if I look at the second diagonal, if I look at quadrants 2 and quadrants 4. Yeah, they're flipped. This one, the sign is positive, cosine is negative. It's reverse in quadrant 4. The sign is negative, the cosine is positive. And one final thing I want to point out is notice in quadrants 1 and 2, what do you notice about the sign? They're both positive, and then what about in quadrants 3 and 4? They're both negative. So that's some just little tidbits to help you remember that. So you do need to know that information. Now we need to determine if the values of the functions are positive or negative. So if we're talking about the sine of 240 degrees, let me add some degree measures here. So this would be 0 degrees at standard position. Here would be 90 degrees. Here would be 180 degrees. Here would be 270 degrees. So if my angle is 240 degrees, in which quadrant would 240 degrees fall? Yeah, 240 degrees would be over here in quadrant 3. So if I'm dealing with an angle in quadrant 3, I need to tell the answer, is the sine value in quadrant 3 going to be positive or negative? So in quadrant 3, is the sine value positive or negative? Negative. So number 1, the answer is negative. Number 2, the cosine of 5 pi over 3. So 5 pi over 3. So now we're counting with radians. And I remember when I was counting by 1 pi over 3, 2 pi over 3, 3 pi over 3 is equal to 180 degrees. Because 3 pi over 3 is equal to what? Pi. And pi is 180 degrees. So 3 pi over 3 would be at 180 degrees. So 4 pi over 3 would be in quadrant 3. And 5 pi over 3 would fall in which quadrant? It would be in quadrant 4. And over here we'd have 6 pi over 3 to give me 2 pi. So 5 pi over 3 has to fall in quadrant 4. So if I'm talking about an angle in quadrant 4, I need to determine would the cosine in quadrant 4 be positive or negative? Yeah, cosine in quadrant 4 would be positive. And then number 3, we have the cosine of 29 pi over 36. So now we'll have to figure out where would that angle terminate, in which quadrant? Huh? Let me put this in radians. So this would be 0. I know over here this would be 6 pi over 6, because what is 6 pi over 6? Pi, and then this would be 12 pi over 6, which would be 2 pi. Then over here would be 18 pi over 6. Over here would be 24 pi over 6. Then over here would be 30 pi over 6. So if 30 pi over 6 falls right here on the x-axis, where would 29 pi over 6 fall in which quadrant? Quadrant 2. So if I'm talking about quadrant 2, is the cosine positive or negative in quadrant 2? Negative. We determined where the angle terminated in which quadrant? Yes, you could convert into degrees. So if you did that, pi would be 180 degrees. And what's 180 degrees divided by 36? 5. So this would be 29 times 5, which would be 145 degrees. And 145 degrees would terminate in which quadrant? 2. So you can work with the radians or you can work with the degrees. Yeah, you could do that too. Okay, now for the reference angle. The definition for a reference angle is going to be the smallest positive acute angle determined by the x-axis and the terminal side of theta. So when you're dealing with a reference angle, it's just going to be the angle between the terminal side and the x-axis. And notice, here's the terminal side, here's the x-axis. So right here would be my reference angle. Here's the terminal side, here's the x-axis, there's my reference angle. Here's the terminal side, here's the x-axis, there's the reference angle. Terminal side, x-axis, there is my final reference angle. Now for the next set, we need to find the reference angle if theta equals 150 degrees. Well, this first one, I'm going to draw it out for you. So here's 0 degrees, here's 180 degrees, so 150 degrees would terminate in quadrant 2. So there's 150 degrees. Now, if I use theta with a subscript of r, that represents my reference angle. So your reference angle is just the angle that's between the terminating side and the x-axis. Well, I know that this is a linear pair. So if this is 150 degrees, what would the reference angle have to be? 30 degrees. So here the answer would be 30 degrees. So the reference angle, or the angle from the terminal side to the x-axis, would have to be 30 degrees. Now, I don't want to have to draw a picture each time. So where could I get the 30 degrees from, mathematically? Yeah, this would be, this terminating side is closest to 180 degrees, so it would be 180 degrees minus 150 degrees, which would give me 30 degrees. So what you have to do is determine, would your terminating side be closer to 180 degrees, 0 degrees, or 360 degrees? Next one, number 5, we have 225 degrees. Would 225 degrees be closer to 180 degrees or 360 degrees? It's closer to 180. Now, if I do the same process as over here, if I did 180 degrees minus 225 degrees, what would that give me? Negative 45 degrees. But for the definition of a reference angle, your reference angle has to be positive. So when that happens, you can just drop the negative or just reverse the order of the subtraction. So if I do 225 degrees minus 180 degrees, that gives me the positive reference angle. So positive 45 degrees. And that next one, 275 degrees. Which x-axis value would it be closer to, 180 degrees or 360 degrees? 360. So this one I'd have to do 360 degrees minus 275 degrees to find that reference angle. And what's 360 minus 275? 85 degrees? 85 degrees. Okay, the next 3 problems, we're still doing the same thing, except now instead of degrees, we are given radians. So if I'm dealing with radians, 5 pi over 3. Working with radians. Here it would be 0, here it would be pi, here is 2 pi. So 5 pi over 3. Now if I'm dealing with pi over 3s, I'm going to make this 3 pi over 3. And instead of 2 pi, I'm going to make this 6 pi over 3. So 5 pi over 3, would that be closer to 3 pi over 3 or 6 pi over 3? 6 pi over 3, or 360 degrees. So we need to do 6 pi over 3 minus 5 pi over 3, and your answer would be pi over 3. Now, when you are working with these, if you want to use degrees, that's fine, but if you are given a radian, your answer needs to be a radian. If you're given a degree, your answer has to be degrees. Next one, number 8, we have 5 pi over 4. So here we're counting by pi over 4, so here would be 0, and instead of pi, I'm going to put 4 pi over 4, and instead of 2 pi, I'm going to put 8 pi over 4. So 5 pi over 4 would be closer to 4 pi over 4 or 8 pi over 4. 4 pi over 4. So here I'll have to subtract 4 pi over 4 to get the positive angle, which would be pi over 4. And then number 9, we're counting by increments of pi over 6. So this would be 0. Instead of pi, I'm going to put 6 pi over 6. And instead of 2 pi, what should I use? 12 pi over 6. So 5 pi over 6, would it be closer to 6 pi over 6 or 12 pi over 6? 6 pi over 6. So those are the two that need to be subtracted. 6 pi over 6 and 5 pi over 6, that difference would be pi over 6. Are you noticing a trend? We had a pi over 6. What was the reference angle? Pi over 6. We had a pi over 4 in the problem. Our reference angle is pi over 4. Okay, now we have our unit circle. We're just really going to work with quadrant 1. So working with quadrant 1, I know in standard position this would be 0 degrees. And up here at the top this would be 90 degrees. We would have 180 degrees, 270 degrees. We're going to go ahead and label all of these in degrees and radians, and we'll just put sines, cosines for quadrant 1 only. Okay, so if this is 0 degrees, if this is 90 degrees, what's half of 90 degrees? So start by adding 45 degrees. So 0 to 45 is 45, plus 45 gives me 90. What's 90 degrees plus 45 degrees? 135 degrees. 135 plus 45 gives me 180. And what's 180 degrees plus 45 degrees? 225 degrees. 225 degrees plus 45 degrees gives me 270 degrees. And what's 270 degrees plus 45 degrees? 315 degrees. And 315 degrees plus 45 degrees gives me 360 degrees. Now, these two pieces that are missing, what are those counting by? 30 degrees. So this would be 30 degrees. 60 degrees. 90 is already marked. This one would be 120 degrees. 150 degrees. 180 degrees is already marked. This would be 210 degrees. 240 degrees. 270 is already marked, so this would be 300 degrees. This would be 330 degrees, 360 degrees. Now, radians. 0 degrees is how many radians? 0. 360 degrees is how many radians? 2 pi. So if 360 is 2 pi, 180 degrees would be pi. And if 90 degrees is half of 180, 90 degrees would be 1/2 pi, or pi over 2. And 45 is half of 90, so what's half of pi over 2? So this would be 1 pi over 4. 2 pi over 4 simplifies to pi over 2. 135 would be 3 pi over 4. 180 degrees would be 4 pi over 4. 225 degrees would be 5 pi over 4. 270 would be 6 pi over 4. And 6 pi over 4 simplifies to 3 pi over 2. The next one, 315 degrees, would be 7 pi over 4. And then at 360 degrees, that would be 8 pi over 4, which is also 2 pi. Now for 30 degrees is what fraction of 180? (30 out of 180 would be 1/6. So 30 degrees would be pi over 6. So 30 degrees would be 1 pi over 6. 60 degrees would be 2 pi over 6. And that simplifies to pi over 3. 3 pi over 6 is also pi over 2. This would be 4 pi over 6, which simplifies to 2 pi over 3. This one would be 5 pi over 6. 6 pi over 6 would be pi. This would be 7 pi over 6. This is technically 8 pi over 6, which simplifies to 4 pi over 3. Then we'd have 9 pi over 6. This one would be 10 pi over 6, and that simplifies to 5 pi over 3. This one would be 11 pi over 6. So now we have finished marking the degrees and the radians. Now we are going to mark the cosines and sines. Remember, when we're dealing with cosine and sine, we write them in ordered pair form. Remember, the cosine is first, the sine is second. So let's do the quadrangles first. So starting right here, if I am right here on the unit circle, I know the radius is what length? 1. So what would that ordered pair be? What would the x value be? The x value is 1, the y value is 0. So 1, 0. So that means the cosine is 1, the sine is 0. At 90 degrees is at the very top of the circle, so write that point as an ordered pair. What would it be? 0, 1. So the cosine is 0, sine is 1 for 90 degrees. At 180 degrees, what's the cosine, write it as an ordered pair. What's the x value? -1, the y value is 0. And at the bottom at 270 degrees, that ordered pair would be 0, negative 1. Now, for quadrant 1, we're going to write these as an ordered pair. These are the values I told you you needed to memorize for our pop quizzes. What was the cosine for 30 degrees? We need a pop quiz right now? We did this Wednesday. Cosine of 30 degrees is square root of 3 over 2. What's the sine of 30 degrees? One half. And then what you need to remember is that 30 degrees and 60 degrees, they're reversed. So instead of square root of 3 over 2, 1 half, it needs to be 1 half for the cosine, square root of 3 over 2 for the sine. And then for 45 degrees, what was the cosine for 45 degrees? Square root of 2 over 2. And what was the sine for 45 degrees? Square root of 2 over 2. Now we are going to base all of our answers today off of these quadrant 1 answers and our knowledge about is the sine or cosine positive or negative in the terminal side or terminal quadrant. Okay, so starting with number 10, the instructions say express each of the following in terms of a reference angle, then find the value of each. So the very first thing we have to do is find the reference angle. And then we have to find the exact value using that unit circle. So for number 10, we have 330 degrees. So if I use theta with a subscript of r, that's talking about the reference angle. So what would the reference angle be for 330 degrees? How far away from the x-axis would it be? How many degrees? 30, because 360 minus 330 would be 30 degrees. So when we're dealing with this particular angle, we need to be referencing our answers for the 30 degrees. But I know in quadrants 1, sine is positive, cosine is positive. Quadrant 3, sine is negative, cosine is negative. Sine is positive in quadrant 2. Cosine is negative, and down here diagonally it's reversed, so the sine is negative, the cosine is positive. So what we need to actually do is we need to find the sine of 30 degrees, and you should have these memorized. What is the sine of 30 degrees? The sine of 30 degrees. 1 half. If you're looking at that unit circle, remember your ordered pair is cosine, comma, sine. So you need to be looking at the second value there. Now, if I'm talking about 330 degrees, 330 degrees is in which quadrant? 4. 330 degrees would be down here. So for my answer, it's 1 half, but I have to decide, should it be a positive 1 half or a negative 1 half, and I determine that by looking at the quadrants. If I'm talking about sine in quadrant 4, should my answer be positive 1 half or negative 1 half? Negative 1 half. So the first thing you need to do is find the reference angle and find the value associated with that trig function for the reference angle. Then you need to determine what is the sine. Is it positive or negative? And you determine that by looking at the quadrant where your angle given terminates. So look at number 11. We have 225 degrees. What would our reference angle be? .45 degrees. It's 45 degrees from the x-axis. So now I need to find the cotangent of 45 degrees. But if I'm finding the cotangent of 45 degrees, well, if tangent is sine over cosine, then cotangent would have to be cosine over sine. Now, what is the cosine of 45 degrees? Square root of 2 over 2. What's the sine of 45 degrees? Square root of 2 over 2. So I know my answer when I divide these is going to be 1. But now I have to decide, is my answer positive 1 or negative 1? So if I'm talking about 225 degrees, in which quadrant does it terminate? Yeah, down here in quadrant 3. So if I'm dealing with cotangent, well, first of all, would the tangent be positive or negative? So if the tangent is positive in quadrant 3, that tells me the cotangent is also positive. You don't have to put the plus sign, but do know it's a positive 1 for the answer. Okay, next one, number 12. If I have sine of 5 pi over 4, what would that reference angle be? Pi over 4. This right here, pi over 4. So if I'm looking up the sine of pi over 4, the sine of pi over 4, I should already know that value. What's the sine of pi over 4? Square root of 2 over 2. Now I have to decide, is my answer going to be positive or negative? So let me redraw this. I know sine and cosine are both positive in quadrant 1. They're both negative in quadrant 3. Sine is positive in quadrant 2. Cosine is negative in quadrant 2. And in quadrant 4 it's reversed. The sine is negative. The cosine is positive. So 5 pi over 4. If I'm counting by pi over 4s, it's 45 degrees. So here would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So 5 pi over 4 would terminate in which quadrant? 3. So the sine in quadrant 3 needs to be negative. So my answer needs to be negative square root of 2 over 2. Next one, number 13. If I have a cosine of 7 pi over 6, what's the reference angle? Pi over 6. And pi over 6 is the same as 30 degrees. So if I'm talking about the cosine of 30 degrees, what's the cosine of 30 degrees? Square root of 3 over 2. Now I have to decide, is it going to be a positive square root of 3 over 2 or a negative square root of 3 over 2? So I have to decide 7 pi over 6, where would that terminate? Well, here's 0, here's 3 pi over 6, here's 6 pi over 6. So 7 pi over 6 would terminate in quadrant 3. So if I'm dealing with the cosine in quadrant 3, would my answer be positive or negative? Negative. So your answer needs to be negative square root of 3 over 2. Now we need to find the exact value of each, so we're doing the same thing. Now we need to find the cosine for 300 degrees. So what would my reference angle be? Yeah, it's 60 degrees away from the x-axis, so 60 degrees. So if I'm looking up the cosine of 60 degrees, what's the cosine of 60 degrees? 1/2. Now I have to decide, is it going to be positive or negative? (300 degrees is in which quadrant? 4. So cosine in quadrant 4 would be positive. So the answer is positive 1/2. Next one, number 15, we have the tangent of pi over 3. So the reference angle is pi over 3, same. Now, if I'm looking for the tangent, remember that tangent is equal to sine over cosine. So what's the sine of pi over 3? Square root of 3 over 2. What's the cosine of pi over 3? 1/2. Here are the 2 and the 2 cancel. So this would be square root of 3 over 1, which is just square root of 3. So if I'm dealing with quadrant, well, pi over 3 would terminate in which quadrant? 1. So if I'm talking about tangent in quadrant 1, sine over cosine would be positive over positive. So this would be positive square root of 3. So everything in quadrant 1 needs to be positive for the answer. Next one, number 16. We have the sine of 3 pi over 4. What's the reference angle here? Pi over 4. What's the sine of pi over 4? Square root of 2 over 2. And 3 pi over 4, I have to decide which quadrant would that terminate in. Well, here's 1 pi over 4, 2 pi over 4. Here is 3 pi over 4. So which quadrant did I terminate in? Quadrant 2. And we were looking for the sign. So is sign positive or negative in quadrant 2? Positive. So the answer is square root of 2 over 2. Okay, I want you to do the next 3. Do 17, 18, and 19. Actually, just do 17 and 19. We'll do 18 together. Okay, number 17. Secant is always paired with which trig function? Cosine. So start with a cosine of 60 degrees. What's a cosine of 60 degrees? 1/2. So if the cosine of 60 degrees is 1/2, what would the secant of 60 degrees equal? 2. And number 19, we have sine of 5 pi over 3. So what would the reference angle be? Pi over 3. And what's the sine of pi over 3? Square root of 3 over 2. And then we have to decide 5 pi over 3 would terminate in which quadrant? So if I'm counting by pi over 3, that would be 60 degrees. So here would be 3 pi over 3. So I'd have 4 pi over 3. 5 pi over 3 would be in quadrant 4, and in quadrant 4, the sine is negative, the cosine is positive. So does my answer need to be positive or negative? Yes, sine is negative in quadrant 4, so negative square root of 3 over 2. Then number 18, we have the cosine of negative 240 degrees. What does a negative angle mean? That means the rotation is going to be clockwise. So this would be negative 90 degrees, negative 180 degrees, negative 270 degrees. So when I'm talking about negative 240 degrees, it's going to be over here in quadrant 2. Now, first of all, what is the reference angle here? Negative 240 is how many degrees from 180? Or negative 180? 60 degrees. So here our reference angle is 60 degrees. From the terminal side to the x-axis, this would be 60 degrees. So what is the cosine of 60 degrees? 1/2. And if I'm in quadrant 2, is this cosine going to be positive or negative? Negative. So sine is positive, cosine is negative. So our answer needs to be negative 1/2 for the cosine. Next one, number 20. We have cosine of 15 pi over 4. What's the reference angle? Pi over 4. And we have to decide in which quadrant would that terminate. But first, what's the cosine of pi over 4? Square root of 2 over 2. We have to decide 15 pi over 4 terminates in which quadrant. Well, this would be 0 pi over 4. This would be 2 pi over 4. 4 pi over 4. I'm not going to keep labeling these. I'll stop in just a second. So this would be 6 pi over 4. Over here would be 8 pi over 4. This would be 10 pi over 4, 12 pi over 4. If this is 14 pi over 4, that means 15 pi over 4 terminates in quadrant 4. So if I'm in quadrant 4, I know the sine is negative, the cosine is positive. So should my answer be positive or negative? Yes, cosine is positive in quadrant 4. Now the last one for this section, number 21, we have the cotangent of 31 pi over 6. So what would the reference angle be? Pi over 6. And if I'm looking for cotangent, well, I know that tangent is sine over cosine, so cotangent is cosine over sine. So what's the cosine of pi over 6? Square root of 3 over 2. What's the sine of pi over 6? 1/2. Those 2's and the denominators will cancel. That gives me square root of 3 over 1, which is just square root of 3. So my answer is going to be square root of 3. I have to decide, is it going to be positive square root of 3 or negative square root of 3. So this time I need to count by pi over 6. And over here, this would have to be 6 pi over 6. So each quadrant, or 90 degrees, we're counting by 3 pi over 6. So this would be 3 pi over 6, 6 pi over 6, 9 pi over 6, 12 pi over 6, 15 pi over 6, 18 pi over 6, 21 pi over 6, 24 pi over 6. Here would be 27 pi over 6. And this one would have to be 30 pi over 6. So if I'm talking about 31 pi over 6, it would terminate in quadrant 3. And in quadrant 3, sine is negative, cosine is negative. So what does that tell me about the tangent? Tangent would be positive, so the cotangent is also positive. Okay, only word problem for today, number 22. The second hand on a clock is 3 centimeters long. How far does its tip travel in 68 seconds? Okay, the first thing, let me draw a small picture. Here's 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. And that's good enough for this. And I know we're starting at 12 o'clock. And they told me the radius is 3 centimeters. And this second hand is going to travel all the way around 1 revolution. And then we're going to stop after 68 seconds. So here would be 60 seconds at 1 complete revolution. So how many more minutes do I need to go around? 8 minutes. So it's going to stop somewhere about here. So we have to figure out what distance did that tip travel. So here we're talking about the arc length. We're talking about the distance around the circle. And there's a formula to calculate arc length. And when we talk about arc length, we use the variable s. And the formula to calculate the arc length, it's theta times the radius. So theta is just our angle, and r is the radius. So the first thing we have to do is to determine theta. So the angle of rotation. So how many degrees total did that tip go around the clock? Well, I know it's going to be an angle over 360 degrees because it made one complete revolution. So they told us it was 68 seconds out of how many total seconds in a minute? 60. Now let's see how many degrees that would be. So I know there's 360 degrees total in the circle. And let's find theta. So 60 times what would give me 360? 6. So what's 68 times 6? 408 degrees. Now your angle has to be in radians. So now we have to convert 408 degrees to radians. And that's what we did yesterday. And how do you convert a degree to radians? Multiply by pi over 180 degrees. So the degrees will cancel. That gives us 408 pi over 180. And that fraction simplifies to what? Yes, 34 pi over 15. So that's theta. So now we're ready to solve. So the formula is arc length is equal to our angle in radians times the radius. And for the angle in radians, we got 34 pi over 15. And they told us in the problem the radius was 3. I'll make this 3 over 1. 3 and 15 have a common factor of 3. So my arc length would be what? What do I have left in the numerator? 34 pi. What's left in the denominator? 5. And here the units they're using is centimeters. So 34 pi over 5 centimeters. Yeah, leave it in terms of pi. So our answer in terms of pi. Just assume, leave it in terms of pi. Okay, now we have some triangle problems. Using the given information, determine the quadrant in which theta is located. Draw a sketch and find the values of the other 5 trig functions. Okay, so for number 23, we're given the cotangent of theta is negative 5/12, and theta is between pi over 2 and pi. So that means theta is in which quadrant? Quadrant 2. So draw a terminal side in quadrant 2. And when you draw your triangle, make sure you draw from the terminal side to the x-axis. And there's our reference angle. It's going to be between the terminal side and the x-axis. Now the trig functions. We'll have sine of theta, cosine of theta, tangent of theta. And what's paired with sine? Cosecant. So we'll have the cosecant of theta, secant of theta, cotangent of theta. And they told us the cotangent is negative 5/12. Remember SOHCAHTOA? Tangent is opposite over adjacent, so cotangent would have to be adjacent over opposite. So they're telling me that the adjacent side to theta would be 5, the opposite side would be 12. One of those has to be negative. Yes, the 5 is on the left side of 0, so it has to be the negative 5. The 12 is above 0, so it's going to be positive. And hopefully you know your Pythagorean triples. This is 5, 12, 13. And hypotenuse is always going to be positive. So now we have all three sides, so now we can quickly write down the answer. So cotangent was negative 5/12. So what would the tangent be? 12 over negative 5. Sine is opposite over hypotenuse. So what would the sine be? 12 over 13. So that means the cosecant would be 13 over 12. For the cosine is adjacent over hypotenuse, so what would the adjacent side be? Yes, negative 5 over 13. So the secant would be 13 over negative 5. Last one. We're given the cosecant of theta is negative 17 over 15, and theta is between negative 90 degrees and positive 90 degrees. So here's 0 degrees. Negative 90 degrees means we're rotating clockwise. Positive 90 degrees means we rotate counterclockwise. So theta right now has a possibility of lying in how many quadrants? 2. It could be in quadrant 1, or it could be in quadrant 4. Now, when you're drawing your triangles, make sure it's always from the terminal side to the x-axis, terminal side to the x-axis. So here's theta, here's theta. And if I'm given cosecant, cosecant is always paired with, so if sine is opposite over hypotenuse, this is hypotenuse over opposite. So the hypotenuse would be 17, and the opposite side would be 15. Yes, one of those has to be a negative. Is it going to be the hypotenuse that's negative? No, so it has to be the opposite side. So one of those triangles is correct. One of them is wrong. Which triangle is wrong? The top one. So we're not dealing with quadrant 1. It's definitely going to be in quadrant 4. How did I know? Because here, if I'm above 0, can I have a negative length? No. Now we need to find the missing side, so we can use Pythagorean theorem. So a squared plus b squared equals c squared. So this would be negative 15 squared plus b squared equals 17 squared. What's negative 15 squared? So 225 plus b squared equals what's 17 squared? 289. Subtract 225 to both sides. So b squared is 64, so that means b is 8. So would that 8 be positive or negative? Yes, it needs to be positive 8. So the sine would be opposite over hypotenuse. So what's the opposite side for theta? Negative 15 over 17. So the cosecant would be 17 over negative 15. Cosine is adjacent over hypotenuse, so what's the adjacent side? 8 to the hypotenuse. So the secant would be 17 over 8. Tangent is opposite over adjacent, or is sine over cosine. Well, the 17s would cancel, and it would be negative 15 over 8. So the cotangent would be 8 over negative 15.